Okay, 2 points A and B are on different sides of O in the path of the particle. The distances of A and B from O are 1 meter and 4 meter respectively. Calculate the shortest time for the particle to travel from A to B. Okay, so you've got to look at this. It's mocked up a sketch here of this, right? You've got to think here, you've got to see here, this is like the center of oscillation, yeah, at O, and A is 1 meter away from it, and B then, the other side, is 4 meters away. Now in this case, A and B are not the extreme points. We worked out earlier on that the amplitude, remember, is 5 meters. Okay, so the amplitude, or the extreme point, would be out here somewhere, wouldn't it? So that distance there would be 5 meters. And then the other side, it would be out here somewhere, yeah? So these points are actually on when they're on their way to the extreme, okay? Now it says here, calculate the shortest time for the particle. Okay, because there are different times you could measure. For instance, you could think about the particle as it's doing SHM like this. Well, it could be going in this direction, yeah? So if it goes in this direction, and then you start counting the time it goes through A, well, it's got to go all the way over here to the extreme and then work its way all the way back until it gets to B. They don't want that time, okay? They want you to work out the shortest time. So as it's doing SHM, like that, yeah, they want you to work out the time it takes as it's coming in this direction. So it's coming in this direction, it goes through A, clock starts, stops at B, clock stops. So as it's going in that direction there, the shortest time it takes to get from A to B, okay? Now we can be really clever how we do that, okay? Because if we try and start timing it from here and ending it there, it's a lot of work. But what we can do, we can use symmetry. So instead of thinking about working out the journey time from A to B like that, what we can do is we can work out the journey time it takes to get from O to B. Okay, thinking as if the initial position is O here, so we can work out that time, and we can also work out the time it takes to get from O to A going this way. We can add up both times. The reason why this works is because of symmetry. Okay, so when it's doing SHM, okay, when it's traveling in this direction, the time it takes to get from O to A is the same as the time it takes to get from A to O. So it doesn't really matter how you work out the timings, okay? We're going to split it up. That's the best way to do this, okay? It is the best way. So consider the time it takes to get from O to A on that journey, because that will be exactly the same time as it would take to get from A to O on its return. And then add it then to the time it takes to get from O to B. So how do we do that? Well, if we think of, and let's write that down, so the time taken from A to B is equal, yeah? Is the same as time it takes to go from O to A added to time it takes from O to B. Okay, so how do we do it? Well, if we start at O, then we've got to use this displacement formula, haven't we, where the initial conditions were said to be that at the beginning it's at the mean point, it's at O. So we can use this formula. So what we can say is, okay, at A, what is x going to equal? Well, at A, x is going to equal 1, isn't it? Okay, x is going to equal 1. Now you might say to me, it should be minus 1, because it's going that way, and we're thinking x is positive in this direction, yeah? This is the direction of increasing x. So you might say minus 1, but you know what, it doesn't matter, because the time it takes to travel there, 1 meter, is the same as it would take to travel 1 meter this way, okay? So we just keep it positive for simplicity. So 1 for x, time it takes to get to here. A is 5, okay? And of course we know omega, we worked that out earlier, is 1.5, right? T. So all you've got to do then is rearrange this to get t. So we take the 5 over, divide by 5, so we get that. Now t is locked up in terms of that sine, so I've got to take the sine over and do sine to the minus 1. And then to get t, of course I've got to deal with that 1.5, then I've got to take that over, so I've got 1 divide by 1.5 times sine to the minus 1 of 1 over 5. So if I work that out, I get my t, so t equals to 0.134, okay? So I do exactly the same thing then. Consider the journey from O to B. So at B, x will equal to, okay, it'll equal to 4, isn't it? So 4 will equal to 5 sine 1.5t, okay? So it's exactly the same as this. So I can just skip these steps and just write this, can't I? I can say 1 divided by 1.5 sine to the minus 1 of, I'm going to check myself, 4/5, isn't it? Yeah. Okay, equals to t. Okay, because it's the one there, isn't it? That now becomes 4 here. So we're going to write 4 in that, which is what I've got here. So t then comes out to be 0.618. So you can see it takes longer, obviously, because it's further. And then you just got to add them up. So the total will equal to 0.134 plus 0.618. So that comes to 0.752 seconds.